Okay, this is the study guide for Miss Lang's Systems of Equations review test she's going to be given. So here we go. First one, checking to see if an ordered pair, which is x and y, is a solution. I'm having to take that x and y and to plug it in not just to the top one, but also into that bottom equation. I need to check both to make sure that point is a true solution. So here I go. I'm going to plug in that first one. I have -2 where that x is. I plug in that 3, and then I have plus y, and that y of course is -5, and that is trying to be equal to -11. So this gives me -6 minus 5, and I can see that that -11 is in fact equal to that one, but I got to make sure I check both before I see if it's a solution or not. So this last one, plugging in 2, and then where that x is, plugging in that 3 right there. I'm sorry, that 2 stays the same. This -2 stays, but where that y is, that's where I plug in that -5 to see if I get -4. That gives me 6 plus 10, and I could see that that 16 is not equal to -4, so that is not a solution. That point 3, -5 is not a solution point. It does not work for both. Has to work for both. All right, here we go. Number 2. For these, you're having to solve them by graphing and then graph them and see where they intersect. So I'll do this top one in blue. I'm going to solve that one for y. So I have -x plus y equal to -3. I'm going to add x to both sides, and that will give me y equals x minus 3. Ready for that one to graph. The one in red, my next one, a little bit harder, but that 3x plus 3y equal to 9. I'm going to subtract 3x on both sides. Bring down that 3y. This is -3x plus 9. Divide everything by 3. And that gives me y equals -x plus 3. That one's ready to graph. So I'll do the one in blue first. Starting at -3. And then that number in front of x, which is a 1 right there, means every time I go right 1, up 1, right 1, up 1, right 1, up 1. Stair step the opposite direction, left 1, down 1. Be able to draw that line accurately using a straight edge because you're trying to see where those two lines intersect exactly. All right, one in red, here I go. Starting at +3, and then that number in front of x, -1, means every time I go right 1, down 1, right 1, down 1, right 1, down 1. Be able to stair step the opposite direction. Draw your line through those, and then write the coordinate accurately where those two lines come together. So I can see where those two lines cross, that x and y number is my solution. And I can see that is 3, 0. To do a check, you got to plug in that 3 and 0 into both. So here I go. I'll do my check in green. So I have negative, and I put that 3 right there, plus 0. Is that equal to -3? And again, I'm plugging that 3 right here, and that 0 right here. I'm plugging it into that first one there. And I can see that when I plug it in, gives me -3 equals -3. That's true, but I got to plug in that bottom one as well. So here I go. I got 3 times 3 plus 3 times 0. Is that give me 9? And I could see that gives me 9 plus 0. That is another 9 equals 9. That one worked. That is the check right there. Plugging it back in, checking your solution. All right, here we go. Next one. In blue, solving that top one, -2x plus 2y equals 4. I'm going to add 2x to both sides. Gives me 2y equals 2x plus 4. And now I'm going to divide everything by 2. And that gives me my equation in blue, y equals 1x, or x plus 2. Let's do the one in red. The one in red, 3x plus 4y equals 8. I'm going to take away 3x on both sides. Bring down this 4y. Bring down the equal, the negative 3x plus 8, and then divide by 4 right there. And that gives me y equals negative 3/4 x plus 2 when I divide 8 and 4. All right, here I go. This one in blue. Start at 2, and then this one over 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1. Be able to stair step the opposite way. Draw that line best you can. All right, the one in red starts at positive 2 on the y-axis 2. That's where they touch. And then right 4, down 3. Be able to stair step left 4, up 3. Stair step the opposite way. And I can see those 2 points intersect right there at the point 0, 2. That's that point of intersection, 0, 2. So when I'm doing that check, I got to plug in the 0 into these x spots, and then I got to plug in this 2 into the y. So let's maybe do my check. How about do my check right here? So here I go. Let's check that first one. So I got negative 2 times 0 plus 2 times that y number, which is 2. Does that equal 4? And you can see that gives me 0 plus 4 equal 4. That is a true statement. 4 equals 4. When I plug in that 0, 2 into the bottom one, 3 times 0 plus 4 times 2, that should equal 8. That gives me 0 plus 8 equals 8. You can see that one works. That one is a solution. That's checking your solution. All right, moving on. These ones just solve by substitution, where this piece right here tells you where you're gonna, or what you're gonna substitute. This tells me where in the other equation am I gonna substitute, right into this y spot in the other place. This tells me what I'm taking and substituting right there. So that first y tells me where in the other equation I'm going to substitute. That second piece tells me what I'm going to take and plug in there. So let me show you where that other y is. I'm going to replace it with that 5x minus 2. Watch. So that bottom equation, I have 2x. I have that 9 still there, but where that y is, I replace that y out of there, and I put that 5x minus 2 piece in there, because that represents what y is on the other equation, and I got that equal to 10. So to solve this, you're going to distribute this 9. Here I go. That gives me 2x plus 45x minus 18 equals 10. I'm going to combine my 2x and my 45x to get 47x minus 18 equals 10. I'm going to plus, oh, whoops, I should have followed instructions. There you go. Here's an example of me not following instructions. This says you do not need to solve the system. Explain which equation you would use to substitute and solve it for one variable. All right, so again, I should always make sure I'm looking at instructions, written instructions, before I start doing any math. This one doesn't want me to solve it. I spent my time solving it when I don't really need to. But I do see that this top equation, this is the one I'm going to use. That 5x minus 2 piece is going to be what I plug in. So that the top equation is the one I'm going to use. I'm going to substitute that y equals 5x, that negative 5x is going to substitute into that y piece. So again, the math that they're seeing here is you're not touching that bottom one, that top one, but the bottom one, you're replacing that y with that 5x minus 2. That's what you're trying to see. That's what you would substitute. All right, for these other ones here, displaying which equation you would use to solve. For these ones up here, man, it's tough. Which one would I want to use to solve? And man, these are brutal because these ones, you got to do brutal math to solve for y. So again, it doesn't matter which one you use, top one or the bottom one, solving this for x or y. I would say y is pretty complicated, so maybe solve this top one for x, because if you take this top one and solve it for x, there's not going to be any negative numbers in it, even though you're going to have some yucky fractions here. But yeah, I would take that one and solve that one for x, and then plug that piece into the other equation's x. That's what I would say for that one. That one's kind of brutal. All right, this next one here, I would say definitely that top one. Looks like I could easily solve that one for y. So if I use my glasses here so I can see, that looks like negative 1/5. So yeah, that top one, I'm pretty sure you're going to solve that top one for y and plug that y in to the other equation's y. So I would take this piece and substitute it into the other equation's y. But again, substitution, they're wanting you to see which equation has x or y that you could solve for easiest. And when that equation's isolated, the variable by itself tells you where in the other equation you're going to substitute, and then that piece it's equal to tells you what you're taking and plugging in there. All right, so here you go. Here's some substitution ones in action. So it looks like this top one here, it would be easy to solve this for x by just adding y to both sides. So that gives me x equals y plus 9. Now to substitution, this x tells you where in the other equation you're going to substitute. You're going to substitute right there. This piece tells me what I'm going to take and substitute right there. So here we go. When I do my substitution, I'm going to have that 2x, but where that x is, that's where I'm going to replace that y plus 9 piece right there. I still have that plus 5y equal 4. This gives me 2y plus 18. Now I need to combine like terms before it becomes a two-step equation. That gives me 7y plus 18 equals 4. I'm going to subtract 18 on both sides and then divide by 7. That gives me 7y equal to negative 14. And then right there, divide by 7. And that gives me only half my coordinate. Negative 14 divided by 7 is negative 2. But remember, that is only half the coordinate. You only know half the answer. That y number is negative 2. Don't put it in the x spot. Make sure you put that number in the y spot. And now for you to find that other variable x, I got to take this negative 2 and plug it into that y spot and solve that one for x. So here I go. When I'm solving that top one for x, I got x minus, and then right there I plug in that minus 2. equal to 9. That turns this into x plus 2 equals 9. And then that one-step equation taken away 2 gives me x equals 7. So make sure you write that in the right spot. And then to just check it real quick, 7 minus 9 is 7 plus 2. Yep, that gives me 9. 2 times 7, 14. 14 minus 10, is that 4? Yep, that one should work. All right, last one. Here we go. This one, this tells me already what I'm going to substitute right into the other equation's x. So here I go, where I have that x right there, I'm going to replace it with that 5y plus 2. That's going to go where that x used to be. And then I still have my minus 4y equals 5. And then again, always combine like terms before you do two-step equations. That gives me 1y plus 2 equals 5. Subtract that 2 on both sides. And that gives me what y is. Y equals 3. And again, remember, that is only half your coordinate, half of it. To find the other half, I got to take that 3 and plug it in for x. I'm sorry, plug in that y and solve for x. So x equals 5. Plug in that number for y, which is 3. Gives me x equals 15 plus 2. Gives me x equals 17. And then let me just do a little quick check. Does 17 equal 15 plus 2? It sure does. Does 17 minus 12 equal 5? It sure does. So I'm pretty sure that point is accurate. All right, moving on. This one we're going to solve doing elimination, but what they want you to do is get it in standard form first. Everything x and y together and all the plain numbers by itself. So I could, for this one, I could subtract 15 on both sides, and that gives me negative 5 equals 2x minus 5y. And if I want to use a math property that lets me just flip it around, I could just switch it. So this is on the left and this is on the right. That is standard form. I got x and y together, and I have all the numbers on the opposite side. And knowing that you could always flip-flop things in math using that associative property, it does not change the math. It's still the same. All right, this guy, I'm going to add 4x to both sides. Give me 4x plus y equal negative 8. Now that's in standard form, right? This last one here, I'm going to add this x, which will give me 47 equals x plus 14y, and then I'm going to flip that around because the math property lets me do that without changing it. Because remember, 6 equals 4 plus 2, which is the same as 4 plus 2 equals 6. Remember, you could switch things around. They're still equal. All right, here we go. Last set. These solving using elimination. So elimination, if I stack it in standard form and just combine, hopefully one of my terms is opposite. The way this is set up, these are the opposites right away. These are the ones that are going to cancel away. They're opposite. So now I have left is this 6x minus 10x, and that gives me negative 4 of those x's. Negative 11 plus 14 is going to give me 3. And let me just check that work, because it looks like it's going to be giving me a fraction here. All right, looks like that's what it is. And then divide by negative 4 right there. And that gives me x is negative 3/4. Oh, this is brutal. Then I need to plug that in and solve for y. So let's plug into that one. There we go. So I got 6x. Plug in this number right here. That gives me, oh my goodness, is this really true? All right, I'm just going to leave that one alone for a little bit here and tackle these other ones here. I'm not sure if she wanted that to be a decimal or fraction or not, but here we go. It looks like that top one, to get that in standard form, if I have that 5y, 6x plus 25, I'm going to subtract 6x on both sides to get that in standard form. Gives me negative 6x plus 5y equal 25. Now I'm going to stack them as is. I got that negative 6x plus 5y equals 25. On the bottom I got negative 2x minus 4y equals 14. Looks like the adjustment I'm going to make is times this whole bottom row by negative 3, and I do that because I want to get the opposite of that negative 6x. I want to times this and get positive 6x and have those cancel. That's why I'm timesing that bottom row by negative 3, and I'm going to have you rewrite it after you've done that. So here I go. That top row stays the same. That bottom row after timesing gives me positive 6x, positive 12y, and then 3 times 14 negative gives me negative 42. Now when I combine these, because these are opposites, they cancel. And then 12y, that gives me 17y, I believe. And then 42 negative plus 25 is negative 17. Divide by 17 gives me y equals negative 1. Then I got to plug that negative 1 in. Make sure I get that y equals negative 1 there. Now I got to take that negative 1 and plug it in to one of my other y's and solve for x. I could use any form I want. I could use the original form I used. I could use the one I rearranged. I'm going to use that bottom one there. So here I go. I got negative 2x minus 4. Plug in that negative 1 right there. Equals negative 2x plus 4. Take away that 4. Gives me negative 2x equals 12. Divide by negative 2. Gives me the other half of my answer, which is negative 6. I believe she wants you to check this solution. So here I go. Let's do the check in green right here. So where that y is, I plug in negative 1. This is that top equation. Where that x is, I plug in negative 6. Let's see if that's true. That gives me negative 5. Is that equal to negative 36 plus 25? Let me see. Nope, so something is wrong. Let's check my work on that one. All right, there's my arithmetic mistake right there. Looks like that should have been 10 right here. So divide by negative 2 gives me negative 5. There it is. All right, now let's do my check. Here I go. 5. Plug in that negative 1 for y. Is that equal to 6 times negative 5 plus 25? That gives me negative 5. Is that equal to negative 30 plus 25? And you can see negative 5 does in fact equal negative 5. Check that bottom one. Negative 2 for x, plug in negative 5 minus 4 for y, plug in negative 1. Is that equal to 14? It should. That gives me 10 plus 4, and I can see, yes, that does equal 14. That was true. All right, let's move on. Last two. Here I go. Looks like I need to get that top one in standard form. So here I go. Let's rearrange this into standard form, adding 5x. That gives me 5x plus y equals negative 2. Now stack them. So I got 5x plus y equal negative 2. That bottom row I got 5x plus y equal to 0. What you want to do is make one of these variables be negative by timesing a whole row by negative 1. I'm going to times that all the way through. That's going to give me 5x plus y on top equal negative 2. On the bottom, I'm going to get negative 5x minus y equals 0. And now it looks like when I combine these, I'm left with that weird 0 equal negative 2. So that tells me this is a no solution. These are parallel lines. And I could tell they're parallel because if I solve this bottom one for y, I could see they both have the same slope but different y-intercepts. Makes those parallel, actually negatively parallel lines right there. All right, this bottom one looks like it's already rearranged, but to make one of my variables go away, maybe to make this become positive 12x, I'm going to times that top row by 6 and rewrite it. Gives me 12x minus 24y equals 60. Bottom row stays negative 12x plus 24y equal negative 60. And then when I add these together, I need you to see that everything cancels away and you're left with 0 equals 0, which is a infinite solution look. Whenever you have something like that, infinite solutions, that means those are the same line. They're like overlapping lines.